Hey guys, welcome to 8.4, where we're talking about calculating and interpreting standard deviation. In class today, we spent time figuring out how the formula for standard deviation works, and we talked a little bit about what it represents, and wanted to give you a little further notes to enhance your understanding of that. So the formula, go ahead and copy that down, is sigma is the square root of all of the data sets gathered together of the difference between each data set and the mean of the whole data squared, all divided by n. So as a review, for example, let's just pick a small data set so we can do quickly. Let's pick out some numbers. Go ahead and just so we have 5 different numbers in our data set. Perhaps it was some data you got from some survey or whatnot, and you want to see how closely packed they are. So for this one right here, what you want to do is you have to find out your mean. And your mean will be all of them added together divided by 5. So I'm going to use my calculator and go ahead and do that. So it'll be 5 plus 7 plus 13 plus 19 plus 21. I got 65. I'm going to divide that by 5. I got 13. So the average is 13. Now we're going to use standard deviation to measure how spread out the data is from the mean. Okay, so you use this to figure out how spread out the data is from here. How spread is it from here? We use the IQR to figure out how spread things out from the median, but we use this one from the mean. All right, so first step is you want to figure out how far apart is 5 from 13. How far apart are they? So that would be 13 minus 5 gives you 8. And then you do the same thing for the rest of the values. We have 7. Okay, that'll be 6. And how far is 13 from 13? Oh, that's nothing. And how far is 19 from 13? 6. How far is 21 from 13? And that would be 8. All right. Next, you want to square all these values. And that would give us 64, 36, 0, 36, and 64. Oh, that's weird. Okay, doesn't normally work out that way. Then you add them all up. Okay, so we have 200. Oh, that's weird. Okay, so far what we've done here, we figured out the mean. That's this value right here. We're kind of going from the inside out of the formula. Next, we figured out the difference between each value and the mean. So here's the difference, and then this is the difference. Now we're going to square it. This is squaring the value, and then we add them all up. So the top would be 200 right now. Next, we have to divide that by n, which is 5. Okay, so divide that by 5. That would give us 40. And lastly, we want to get the square root of 40, which will give us 6.3, about 6.3. And this is the standard deviation. So we're measuring how spread out data is from the mean, okay, which was 13. So on average, they're spread out at 6.3. Now, the real measure of standard deviation is how spread out data is. So let's do this. Why don't we test it out on some really spread out information? And you could use your calculator so you can enter the data so you don't have to do all of the work. Your calculator should be able to give you this. You can use your apps, those stat graph apps. Okay, let me see, make a new page. All right, so let's test this out on some really spread out data. For example, let's make up some numbers. 1, 100, 500, and 1,000. This data is very spread out, as you can see. All right, so go ahead and enter that data into your calculator. Okay, I'm going to enter now. Remember, the app is called Stat Calculator, something like that. Stat Calculator Graphing. Stat Calc. So I'm going to enter that data into my stat calculator. I'm going to put 1, 100, 500, 1,000. Okay, stat calculator, and I have my mean is okay. My mean on this one was 400. It's my average, and then my theta, excuse me, my sigma, which is my standard deviation, in my calculator, it says 393. Okay, so what this means is this is a very spread out data, and obviously you can see it from here. Okay, so it's a very spread out. So we're measuring how far these are from the mean. Now let's do another one that's really, really compact, really tight. Okay. Now look at this. Okay, this data is very compact. All right, so let's use our calculator to enter that data. Okay, I'm going to put starting at 2, 3, 4, 5, 6, and then I'm going to use that. All right, my mean is 4. That's my average, and then my standard deviation is 1.4. Now notice how this number is really small compared to this one. It's very spread out. It's telling you it's a very spread out number. The numbers are very far apart from the mean. And this was 1.4. So it's getting really close to 1, or it's getting close to 0. So the smaller the number, the tighter the numbers are together, the more compressed they are, the more they're close together. Like this one, they're very close together. Now let's test out the most extreme case of all. Okay, here's the last one. All right, here's my data. It's all the same numbers, but everybody has them. And you'll see the difference here. For example, my mean will definitely be 8. My average will definitely be 8. Okay. All right, and then my standard variance will be, let's see, type this in. So they're all 0 spaces from 8. So look at this, how interesting. My standard deviation is 0 because they're the exact same number. They're not spaced out at all. They're identical. All right, so here's a really good idea of what standard deviation does for you, what the measurement means. Okay, it measures how tightly compressed the data is, how spread out they are, if at all, or are they really tightly compacted. And here's a good example of all 3 sections. Okay, this is a review, really spread out. You get a big standard deviation, pretty lined up. You have a very close to 1. And of course, the super compact would be 0. There's 0 spaces apart. This This could probably get even less, a smaller number if it was like 2 and then 2.1 and then 2.2 and 2.3, 2.4. Go ahead and test that out and post your understanding of that and see what kind of numbers you got. On the tutorial, post which numbers you use and what the standard deviation was and explain what it means. All right, now we can start doing the homework. Go ahead and pause that while I get this ready. All right, so for number one, there's a pre-done example for you. Here is the data right here, 0, 3, 6, 7, 9. The numbers are somewhat close together. They're not too spread out, so the answer shouldn't be that big of a number. So first they're finding out the mean, and this is without a calculator, okay? So without a stat calculator, all right? You can use a regular calculator. So go ahead and do the hard work. Add them all up, divided by 5. The mean is 5. Next, find out how far apart each of these numbers is from 5. Okay, so how far apart is 0 from 5? That would be 5, and 5 squared will be 25. How far apart is 3 from 5? So that would be 2. 2 squared is 4, and so on. Do all those values and square them. After all that, add them all up. Okay, this is them all added all up. After that, divided by how many numbers there are. There are 5 numbers. And the last step is to get the square root of that, which gives you 3.1. And this is the measurement of how packed they are. So you get a low value of 3. It means they're pretty compact, okay? But they're not super compact like the other ones. And you can kind of tell right here. For number 2, looks like they did most of the beginning, okay? So you have to find out the mean, add them up, divide by 6, and then figure out the distance from the mean and squared, and figure out the rest of those numbers. Then add them all up, divide by 6, and then get the square root. Go ahead and do that and pause it right now. All right, number 5, the data is represented by a dot plot, okay? All right, you're going to have to figure out standard deviation of this, okay? So, you have to analyze this. You can't just look at it and say, oh, I don't know what to do. Look at it. This is a 2. There's only 2, so your first number is 2. There's 2 number 3s. So we do have data. We have a 2. We have a 3, we have 2 3s, we have 3 4s, okay, and then we have 2 5s, and so on, and we have a 6. Okay, so your goal is to figure out the standard deviation of this. And I'm assuming that the number is going to be really close to 1 because the numbers are really compact. So go ahead and find the mean. All right, add them all up, divided by how many they are, and then find the standard deviation. And you could use the idea on an example on problems in the previous page to figure out that. Number 7, calculate the mean and standard deviation of each given set using a graphing calculator. Okay, now you can use your calculator. All right, this is now you can just go ahead and enter in all the data and give us your sigma. Okay, and the mean too. Looks like you need the mean as well. Number 8, same thing, use your calculator. Remember, there's apps, and if you don't have an app or a calculator, go online and type in how to use standard deviation. There are free tools to use out there. You gotta Google them. You could put TI-83 simulator. Okay, you can go on Google or YouTube and it'll show you how to do it, how to download it, and how to use it. It'll basically be your calculator right in front of you on the computer. You could type them the same way as if you were typing it in the regular calculator. In number 11, you're going to do the same thing as you did on number 5. Okay? Make your list. And look at number 11, the data is more spread out so that the standard deviation should be a bigger number than you get on number 5. Go ahead and pause it while you do that. I'm going to turn the page. All right, this is just a little review for your unit test. You have to write a system of linear equations and then solve it. Any method, okay? Rachel needs to print out some digital photos. She's trying to choose between lighting fast photo and snappy chat. So she's going to be comparing, right? She's doing a versus, one versus the other. So you try to figure out, more than likely, you're going to have this type of equation. All right, so you're going to be plugging in your slope, which is how much is going to be charging per. If this is per, is usually a slope, 20 cents per, and then the base fee is usually your y-intercept. And you want to set them up equal to each other since you have y is equal on both sides. So go ahead and do that as well, just as part of your review. Do it very neatly, very carefully, and very precise in your calculations. All right, guys, go ahead and post your understanding of standard deviation, and go ahead and shoot some Schoology pictures so you guys can discuss amongst yourselves and ask me questions as well. Okay? Have fun. Bye-bye.